Welcome to my channel where we uncover the secrets of the past. Today we're diving into the technology of Nazi Germany that was ahead of its time. Prepare to learn the historical origins of advanced German technology in World War II. The technological advances made by German engineers during World War II spanned a variety of fields, including aviation, missile technology, and electronics. Their work, in creating the latest pieces of equipment, driven by a desire for wonder weapons and qualitative superiority, changed the landscape of military science. Our first stop on this historical journey is the groundbreaking V-2 rocket. Crafted by the brilliant mind of Wernher von Braun and his team, this rocket marked the world's first long-range guided ballistic missile. Launched in 1944, the V-2 reached the edge of space before descending to its target at unimaginable speeds, laying the foundation for future space exploration. One of the key technical innovations of the V-2 was its liquid-fueled engine. Unlike earlier rockets that used solid fuel, the V-2 utilized a combination of liquid oxygen and alcohol. This allowed for more precise control over the propulsion system, enabling greater range and accuracy. Main technical characteristics of the missile. Type: ballistic missile. Length: around 14 meters, 46 feet, diameter, approximately 1.65 meters, 5.4 feet, wingspan, for stabilization during descent. About 3.56 meters, 11.7 feet, power plant. Liquid-fueled engine using a combination of liquid oxygen and ethanol, later changed to liquid oxygen and hydrazine. Thrust: approximately 56,000 pounds, 250 kilonewtons. Range: approximately 200 miles, 320 kilometers. Speed: supersonic, reaching speeds of over 5,000 kilometers per hour, 3,100 miles per hour. Payload: high explosive warhead of around 2,200 pounds, 1,000 kilograms. Guidance system: inertial guidance system using gyroscopes and accelerometers. Launch method: vertical launch from ground-based mobile launch pads. Operational ceiling: reaching altitudes of up to 189 kilometers, 118 miles. The V-2's impact went beyond its role as a wartime weapon and left an indelible mark on the trajectory of space exploration. The lessons learned during its development became a cornerstone in the dawn of space exploration beyond Earth's atmosphere. The engineers and scientists involved in the V-2 program, including Wernher von Braun, played a key role in shaping the space programs of the United States and the Soviet Union during the Cold War, which ultimately led to human spaceflight and exploration of celestial bodies. The V-2 missile serves as a symbol reflecting both the risks and potential associated with advanced technology during the war. Although its development and use could no longer change the course of World War II, it had a significant impact on the development of missile technology and space exploration in the post-war era. Next on the list is the Horten 9, a revolutionary jet-powered flying wing designed by the Horten brothers. Imagine a stealthy jet-powered flying wing in the 1940s. This futuristic aircraft influenced modern-day stealth technology, showcasing the avant-garde thinking of Nazi Germany's aviation engineers. The sheer innovation embedded in this design is particularly remarkable, considering it emerged in the 1940s, an era that did not commonly associate itself with advanced jet propulsion, let alone the concept of a stealthy, flying wing. Technical specifications of the Horten 9. Type: jet-powered flying wing. Engines: initially equipped with two Junkers Jumo turbojet engines. Wingspan: approximately 16.76 meters, 55 feet. Length: approximately 7.5 meters, 24 feet 7 inches. Height: approximately 2.8 meters, 9 feet 2 inches. Maximum speed: estimated to be around 977 kilometers per hour, 607 miles per hour. Range: approximately 1,000 kilometers, 621 miles. Armament: originally designed to be equipped with forward-facing Mk108 30mm cannon. Crew: intended for a single pilot. First flight: the exact date of the first flight is uncertain, but it is believed to have occurred in late 1944. The Horten 9 epitomizes the visionary thinking of Nazi Germany's aviation engineers, challenging conventional limits. A 1940s jet-powered flying wing, it showcased foresight beyond its time, impacting both its era's aircraft design and modern stealth technology. With a radical design and early jet propulsion, it broke aviation norms, influencing future aerospace engineering. The Horton 9's impact on stealth technology and subsequent aircraft generations shaped post-war military aviation and beyond. Now, let's soar into the skies with the Messerschmitt Me-262, the world's first operational jet-powered fighter aircraft. During a time when propellers dominated the skies, the Me-262 changed the game, setting the stage for post-war jet development and leaving an indelible mark on aviation history. The Messerschmitt Me-262, developed by the German engineer Willy Messerschmitt during World War II, was the world's first operational jet-powered fighter aircraft. Its development began in the early 1940s, and it first flew in 1942. Due to various issues, including engine development challenges and resource shortages, it didn't become fully operational until 1944. The Me-262 was a revolutionary aircraft, featuring twin Junkers Jumo engines and a sleek, aerodynamic design. It had a top speed of around 870 km per hour, 540 miles per hour, and was armed with 430mm Mk108 cannon. Its jet engines gave it a significant speed advantage over traditional propeller-driven aircraft of the time. The Me-262 was initially designed as a high-speed bomber interceptor, aiming to counter the Allied bombing raids over Germany. It had a considerable impact on air combat, demonstrating the potential of jet propulsion. The aircraft's speed allowed it to attack Allied bombers with relative impunity. However, its late introduction and production delays limited its overall impact on the outcome of the war. The Messerschmitt Me-262, a groundbreaking jet-powered fighter, played a pivotal role in aviation history, influencing the development of future military and civilian aircraft. Despite its late deployment limiting its impact on World War II, the Me-262 stands as a symbol of innovation and the changing nature of aerial warfare, with lasting effects on post-war aviation. In the early 1940s, Germany developed a groundbreaking submarine design known as the Type 21. This submarine marked a significant departure from previous models, boasting a sleek shape and streamlined hull for improved underwater performance. The outer design included small, streamlined turrets and retractable hydrophones, reducing its acoustic signature. Constructed in 9 modular sections to counter Allied bombardments, the pressure hull was made of a 1-inch thick aluminum alloy, allowing the submarine to potentially dive up to 240 to 280 meters. The Type 21's innovations extended to its internal components, particularly its propulsion system. Unlike earlier submarines, it featured electric motors for submerged movement, supported by massive battery packs charged by diesel engines on the surface. The Type 21's underwater capabilities were unparalleled, offering an impressive endurance of 75 hours at low speed due to its larger battery packs. With 2 6-cylinder diesel engines producing 3,900 horsepower for surface movement, the submarine could also reach remarkable speeds of 15.9 to 17 knots underwater. The submarine's armament system underwent a revolutionary change. Instead of the traditional torpedo loading system, the Type 21 utilized an early autoloader, allowing it to launch 18 torpedoes in under 20 minutes. The introduction of a sophisticated sonar array eliminated the need to reach periscope depth for target identification. While the Type 21 initially planned to incorporate the innovative Walter turbine, it was later abandoned in favor of larger battery packs. The submarine also intended to use Project Ursel, a rocket firing system for self-defense against surface ships, although it was never implemented. Despite its promising design, only 118 Type 21 submarines were completed, with just 2, U-2511 and U-3008, seeing service before the war's end. Post-war examination revealed structural issues and design flaws, hampering their actual capabilities. However, the Type 21's influence endured, shaping submarine designs worldwide. The United States, Britain, and the Soviet Union drew inspiration, incorporating streamlined hull designs and other features into their post-war submarines. Today, the Wilhelm Bauer, originally U-2540, stands as a museum ship in Bremerhaven, Germany, providing a tangible link to the legacy of the Type 21. While these submarines did not alter the course of World War II, their innovations laid the foundation for the evolution of submarine technology, leaving an enduring mark on naval history. The Arado 234 was the world's first operational jet-powered bomber. This German aircraft played a crucial role in reconnaissance and bombing missions, demonstrating the potential of jet propulsion in strategic warfare. The Arado 234, developed by the German aviation company Arado, made its first flight in 1943 and entered service in 1944. This sleek and futuristic-looking aircraft was ahead of its time and marked a significant leap in aviation technology. The AR-234 was initially designed as a reconnaissance aircraft but was later adapted for use as a bomber. Its streamlined design and twin engines set it apart from traditional propeller-driven bombers, making it a true pioneer in the jet age. Now, let's talk about what made the Arado 234 a revolutionary aircraft. First and foremost, the jet engines. The AR-234 was powered by the Junkers Jumo 004 engines, which were the world's first operational jet engines on a bomber. This innovation provided the AR-234 with a significant speed advantage over its piston engine counterparts. The jet-powered design allowed the AR-234 to reach speeds of around 735 km per hour, 457 miles per hour, making it incredibly difficult for enemy aircraft to intercept. Additionally, the aircraft's high-speed performance made it well-suited for reconnaissance missions deep into enemy territory. The AR-234's first operational mission took place in August 1944, and it was involved in strategic bombing raids and reconnaissance flights until the end of the war. Despite its late introduction, the AR-234 showcased the potential of jet-powered bombers and laid the groundwork for future developments in aviation technology. The success and lessons learned from the AR-234 played a crucial role in shaping the future of jet-powered bombers. Its design influenced subsequent generations of aircraft, and its technological advancements paved the way for the development of faster, more efficient bombers. The Arado 234 demonstrated the strategic advantages of jet propulsion, influencing the design of Cold War-era bombers and contributing to the evolution of modern aviation. The lessons learned from this pioneering aircraft continue to echo in the halls of aviation history. Now, let's take a look at the V-1 flying bomb. This unmanned, pulse jet-powered missile was the forerunner of today's cruise missiles. Launched from the air and from the ground, the V-1 was a testament to Germany's early experience with unmanned aerial warfare. In the shadow of World War II, a secret project known as the V-1, or Vergeltungswaffe 1, emerged in the laboratories of Nazi Germany. This weapon of retaliation, shrouded in mystery, was destined to become one of the pioneering guided missiles in history. Designed as a retaliatory weapon, the V-1 was given an ominous name reflecting its intended strike against Allied forces. Development of this advanced cruise missile began in the early 1940s and culminated in its first combat launch in 1944. Imagine this. A pilotless winged machine cutting through the air with a distinctive whirring sound, a sign of a pulse jet engine. In its heyday, the pulse jet engine was a marvel of engineering, providing a simple but highly efficient means of transportation. The wingspan of this sleek, formidable aircraft was 5.3 meters, 17 feet, and about 8.5 meters, 28 feet, long. The 850 kilogram, 1,870-pound, warhead had an impressive range of about 250 miles, posing a formidable threat to England. As the war progressed, V-1s, often launched from ground ramps and later air-launched from modified aircraft, rained down on populated areas of Britain, bringing panic and fear among civilians. In response to the V-1 menace, inventive countermeasures took center stage. Anti-aircraft guns strategically positioned along the English coast faced challenges due to the V-1's speed and low altitude. The introduction of non-contact fuses and radar-based fire control systems significantly boosted defense, achieving a remarkable success rate. Interceptor aircraft, notably the Hawker Tempest, played a crucial role. Tempest pilots disrupted the V-1's gyroscopic guidance, sending them into uncontrolled dives. Specially modified P-47M Thunderbolts and Agile fighters further enhanced interception capabilities. While the V-1 may not have been as accurate as its successors, its legacy remains in history as it laid the foundation for the development of guided missile technology. It was the first harbinger of long-range unmanned aerial attack capabilities. After the war ended, the Allies and the Axis nations learned invaluable lessons from this ominous creation. The V-1's role as a precursor to modern cruise missiles is truly immeasurable, its impact echoing in post-war military strategy and the profound technological advances that followed. The development and use of the V-1 served as the catalyst that gave rise to the modern guided missile systems now recorded in the annals of history. Our journey continues with the story of the creation of the Fritz X bomb. Born out of the turmoil of World War II, this German precision-guided bomb had its roots in the mid-1930s. As tensions rose, German engineers began experimenting with the concept of guided munitions. Developed by Ruhrstahl, the Fritz X bomb, after all tests, made its combat debut in 1943. The Fritz X wasn't just another bomb. It represented a leap forward in military technology, showcasing Germany's early endeavors in the realm of guided munitions. Now, let's dissect what made the Fritz X truly revolutionary. This precision-guided bomb, weighing approximately 1,400 kilograms, 3,086 pounds, and measuring around 3.3 meters, 10.8 feet, in length, was no ordinary weapon. What set it apart were its aerodynamic design, wings, and stabilizing fins that enhanced stability during descent. However, the pièce de résistance was its radio-controlled guidance system. This innovative feature allowed operators to adjust the bomb's trajectory mid-flight, making it a formidable adversary against heavily armored targets such as warships and bunkers. Moving into the theater of war, the Fritz X proved its mettle during numerous naval and ground operations. One of its standout moments was the 1943 attack on the Italian battleship Roma, where the Fritz X played a pivotal role in its sinking. The bomb's precision-guided capabilities made it a potent tool for targeting well-protected enemy assets. Deployed in both the European and Mediterranean theaters, the Fritz X showcased its effectiveness against a variety of targets. Its impact on naval warfare was particularly noteworthy, underscoring the strategic advantage of precision-guided munitions. Fast forward to the aftermath of World War II, and the Fritz X's influence on bomb development becomes apparent. The success and lessons learned from this early guided bomb contributed to shaping post-war aerial warfare technology. The Fritz X laid the groundwork for the evolution of guided munitions. Its impact on accuracy and penetration against fortified targets influenced the trajectory of bomb technology, setting the stage for the development of guided missiles and smart bombs we witness today. The next development ahead of its time was the X-4, an innovative guided air-to-air missile created by German ingenuity. Developed by company Ruhrstahl AG, the X-4 came into existence during the tumultuous years of World War II. Initially conceptualized in the late 1930s, its development gained momentum in the early 1940s, and it was deployed for operational use later in the war. The X-4 represented a significant leap forward in aerial warfare technology, showcasing Germany's commitment to pushing the boundaries of guided missile systems. Now, let's unravel the characteristics that made the X-4 stand out. This air-to-air guided missile was designed with a length of approximately 3 meters, 9.8 feet, and a wingspan of around 0.6 meters, 2 feet. It featured 4 small wings that provided stability during flight. What set the X-4 apart was its innovative guidance system. Unlike traditional unguided rockets, the X-4 was equipped with a wire-guided mechanism, allowing the operator to steer the missile remotely toward its target. This feature marked a significant advancement in precision targeting during aerial combat. The X-4 had limited use during the later stages of World War II. However, it was primarily an experimental weapon and was not widely used in combat. The chaotic conditions towards the end of the war meant that the X-4 did not have a significant impact on air warfare tactics. As we shift to the post-war era, the influence of the X-4 on bomber development becomes evident. While the missile itself didn't directly shape post-war innovations, the concepts and lessons learned from its wire-guided technology contributed to the evolution of guided missile systems in the decades that followed. The X-4 laid the groundwork for future developments in air-to-air missile technology. Its wire-guided system and emphasis on precision targeting influenced subsequent generations of guided missiles, playing a role in shaping the modern landscape of aerial warfare. Our journey continues with the story of Wasserfall, the German surface-to-air missile that emerged during World War II. Developed as part of the German rocket program, the Wasserfall had its origins in the late 1930s. The project gained momentum as the war escalated, and by 1943 Wasserfall had become a tangible force in the German arsenal. Wasserfall wasn't just another missile, it was a testament to the rapidly advancing rocket technology of its time. The project aimed to create an effective surface-to-air missile system to counter Allied bombing raids. These are the characteristics that made the Wasserfall outstanding in the field of surface-to-air missiles at the time. At 6.7 meters, 22 feet, long and with a wingspan of 3.56 meters, 11.6 feet, the Wasserfall was a formidable weapon. Its key innovation was its liquid fuel propulsion system, which provided flexibility and precision targeting. The missile's guidance system was also noteworthy. Wasserfall utilized a radio command guidance system, where operators on the ground could control its flight path, making it a responsive and adaptive weapon against airborne threats. The German Wasserfall surface-to-air missile entered service in the latter stages of World War II. Deployed primarily as a defensive measure against Allied bombing raids, the Wasserfall was designed to intercept and neutralize incoming aircraft. Though limited in its operational use due to the challenging circumstances of the final years of the war, Wasserfall did see some action. Its deployment showcased the evolving tactics of air defense, marking a notable chapter in the history of missile technology. While the missile itself didn't directly shape post-war innovations, the knowledge gained from its development and use contributed to the broader evolution of missile and air defense systems. Wasserfall's legacy lingered in the strategic thinking of military planners. Lessons learned from its radio command guidance system and its role in air defense influenced the development of subsequent generations of surface-to-air missiles, contributing to the sophisticated systems we see today. Before we dive into the details of Nazi UFOs, let's take a look at the historical realities that led Nazi Germany to embark on the creation of wonder weapons. When the course of World War II turned against Germany, Hitler and the entire Nazi top brass sought unconventional solutions to gain an advantage over the Allied forces. Imagine disc-shaped models, unlike anything conventional at the time. These weren't just your run-of-the-mill planes, they were prototypes of a revolutionary aerospace system. The designs were so radical that traditional jet engines could only play a supporting role. Central to these pioneering projects were the scientists and leading experts of the Third Reich. They played a crucial role in developing what they called wonder weapons, Wunderwaffen. This term was used to describe exceptionally powerful and revolutionary military technology. It reflected the idea that these weapons were not just ordinary, they were considered extraordinary and far superior to anything else that existed at the time. The scientists and experts behind these projects sought to create something that would give their side a significant advantage in warfare. The leading experts involved in the development and testing of the latest disc-shaped aircraft were not just scientists and engineers. They were the designers of what the Third Reich called wonder weapons. The term wonder weapon captures the concept of qualitative superiority that was at the heart of these projects. The goal was not just to create an advanced weapon, but to create something beyond conventional understanding, a cutting-edge weapon that would change the balance of power on the battlefield. Let's take a look at 3 variants of the most famous flying disc-shaped vehicles, UFOs, allegedly developed during the war in Nazi Germany. Haunebu. Developed in Nazi Germany at a secret base in Wenceslaus Mine, Czechoslovakia. Diameter: approximately 25 meters. Height: approximately 5 meters. Engine type: presumably a Thule-Triebwerk engine, powered by an electromagnetic field and inspired by Victor Schauberger's concept. Airspeed: capable of reaching speeds of up to 7,000 km per hour. The Haunebu, if it did exist, remains a mysterious part of UFO legend. There are claims of sightings and encounters, but no concrete evidence has been presented. Some conspiracy theories suggest that remnants of this technology influenced post-war aerospace developments. Vril. Developed in Nazi Germany by the Vril Society, a secret organization interested in esoteric and paranormal phenomena. Diameter: approximately 30 meters in diameter. Height: approximately 7 meters. Engine type: powered by the Vril Tri-Generator, an advanced power source based on the Vril Society's alleged communication with extraterrestrial beings. Flight speed: allegedly capable of speeds in excess of 12,000 km per hour. Like Haunebu, Vril remains speculative, with no concrete evidence to support its existence. The influence of the Vril Society on post-war occultism and conspiracy theories gives its legacy added mystique. Die Glock. The bell, supposedly developed in Nazi Germany at a secret facility near the Wenceslaus Mine, Czechoslovakia. Diameter: approximately 2.7 meters. Height: approximately 3.7 meters. Engine type: described as a mysterious anti-gravity propulsion system powered by red mercury or other exotic materials. Flight speed: theoretical possibilities include anti-gravity thrust, but specific speeds are unknown. Die Glock remains the subject of speculation and debate. Some claim it was part of cutting-edge propulsion research, while skeptics claim it was a misinterpretation or fabrication. His legacy lives on in conspiracy theories about secret Nazi technology and its potential impact on post-war scientific research. Despite the technological achievements of German experts at the time, it is important to recognize the grim realities that accompanied these innovations. Forced labor of concentration camp inmates was used to work at these secret facilities. These men participated against their will in the development of wonder weapons. Once the projects were completed, they were often destroyed, a heinous crime against the backdrop of the technological advances of the era. Prisoners from concentration camps were forced to contribute to these projects, and their tragic fate, including extermination after completion, has contributed to the limited information we have about these developments. However, the lack of reliable information about these developments can be attributed not only to the secretive nature of the Third Reich but also to the Allies' implementation of denial programs. These programs were aimed at maintaining secrecy and prioritizing their own advancements in the post-war era. Germany's V-2 missile, developed during World War II, was the world's first long-range guided ballistic missile. It represented a significant leap in rocket technology, laying the foundation for future space exploration. The Horten H-09 was an innovative flying wing aircraft designed by the Horten brothers. It showcased advanced aerodynamics and was intended as a high-speed reconnaissance aircraft with a reduced radar cross-section. Germany's Messerschmitt Me-262 was the world's first operational jet-powered fighter aircraft. Its speed and advanced design posed a significant threat to Allied aircraft, although production challenges limited its impact on the war. The Type 21 U-boats was a German submarine designed for extended underwater operations. Its streamlined hull and advanced propulsion systems allowed for silent and stealthy maneuvers, making it a formidable adversary in naval warfare. The Arado 234 was the world's first operational jet-powered bomber. This German aircraft played a crucial role in reconnaissance and bombing missions, demonstrating the potential of jet propulsion in strategic warfare. The V-1, or Buzz bomb, was an early cruise missile used by Germany during World War II. Launched from aircraft or ground facilities, it targeted London and other Allied cities, symbolizing the advent of guided missile technology. The Fritz X was a German precision-guided, armor-piercing bomb, used during World War II. Developed by Ruhrstahl, it was one of the earliest guided munitions, showcasing Germany's advancements in precision bombing technology. The X-4 was a German air-to-air guided missile developed by Ruhrstahl. Employed during World War II, it demonstrated early attempts at creating air-launched guided missiles, showcasing Germany's pioneering efforts in aerial warfare technology. The Wasserfall was a German surface-to-air missile developed during World War II. It represented an early attempt at creating guided anti-aircraft missiles, demonstrating Germany's innovative strides in aerial defense technology. Nazi Germany's UFOs are German experimental disc-shaped flying machines from World War II. Diving deeper into the enigma of Nazi Germany's UFOs, these experimental disc-shaped flying machines, shrouded in secrecy, captivate the imagination. While the existence of these saucers continues to be a topic of debate, their mere speculation adds an intriguing layer to Germany's technological pursuits during World War II. If you liked learning about history, the evolution of technology, and how it affects our lives, make sure to return here for more insights and information.